Okay, we are going to start chapter 12 here today. This is the chapter on trig functions. And this particular lesson should feel like a little bit of review because you would have had an introduction to at least some of this material in geometry. We're going to be looking at actually 6 trig functions, 3 of which you would have been introduced previously in geometry, and that's sine, cosine, and tangent. And then you're probably less familiar with these other 3, cosecant, secant, and cotangent. We're going to be using these trig functions as they relate specifically to right triangles. So I want you to look at this right triangle pictured over here. We know right triangles are triangles that have a right angle in them. And so we always, when we talk about right triangles, we usually give specific names to their sides. Okay, oftentimes we use this symbol right here. This is a Greek letter of the alphabet. It's pronounced theta, and we put that theta symbol in one of our 2 acute angles, and then we name kind of all the other sides. So the side that is opposite the 90-degree angle, that's always called the hypotenuse. If my theta symbol is right here, this is kind of my angle of focus, then I would refer to this leg here as being the adjacent leg. Adjacent is really just another word for side. It means that this side is right beside the angle I'm talking about. It's adjacent to it. And then this side here we would refer to as being the opposite leg, because clearly it is directly opposite the angle we're referring to. Now, if I moved the theta symbol up here, well, now I would refer to this side here as being the adjacent leg, and I would refer to this side here as being the opposite leg. When you were introduced to the 3 basic trig functions in geometry last year, I'm sure that your teacher had shown you this acronym that is pronounced SO, CA, TOA, as a quick way to kind of remember how the ratios are for sine, cosine, and tangent. Okay, you can see pictured over here that sine of an angle is always the opposite leg divided by the hypotenuse. So that's what this is, opposite divided by hypotenuse. Cosine of an angle is the adjacent leg divided by hypotenuse. That's what this is referencing. And then tangent is opposite over adjacent, which is what this is referencing here. Okay. Now, there are 3 new trig functions. This one is pronounced cosecant, this one is pronounced secant, and this one is pronounced cotangent. Now, what you'll notice about these 3 new trig functions, how they relate to the 3 older trig functions that you've already been introduced to, is it looks like these are just merely the reciprocals of each of the 3 initial trig functions here. And so what you really, I don't have a handy acronym like SOCA, TOA here to memorize these, but you don't necessarily have to memorize these so much as you just need to learn which one of these is the reciprocal partner to one of the 3 original trig functions. Now, this last one is pretty easy because it makes sense that tangent and then cotangent kind of pair up together. And so cotangent is merely the reciprocal of tangent. Here's the best tip that I can kind of give you to sort of memorize these other pairings. As you look at each pair, and I put them directly across from each other here, one of each of the 2 words, and only one, starts out with the pronunciation co. So here we have sine, it is paired up with cosecant. Here we have cosine, so this already starts out with the pronunciation co, so it gets paired up with secant. And then tangent is paired with cotangent. So basically, one of the 2 words in each of these pairings starts out with the pronunciation co. So you're not going to have cosine paired with cosecant because those both start out with the pronunciation co. Okay, so that is kind of a helpful way maybe to try to memorize what those relationships are. So what we're going to be doing down here is we are not using our calculator at all on any of these problems on this notes page until we get to the last few problems on the back. So please keep that in mind, that you should not be pressing the sine, cosine, tangent buttons on your calculator for any of this here. This is asking us to find the exact values of the 6 trig functions for theta. So I'm just going to highlight in the triangle where the theta symbol is located. Okay, you'll notice in this example here that's done for you, sometimes I like to put a little arc here at the angle where theta is. We're just going to construct in the first column the fractions for sine, cosine, and tangent, building opposite over hypotenuse for sine, adjacent over hypotenuse for cosine, and then opposite over adjacent for tangent. And then over here, we don't even really have to look at the triangle anymore. We can just grab each of these fractions and just flip them and make them the reciprocal. Okay, so let's go ahead and kind of set up a space here for us to do sine, cosine, and tangent in the left column. And then I'm just going to go ahead and put the reciprocal partner right across from each of those originals, cosecant, secant, and cotangent. Okay, so let's build our first fraction here. I'm going to go ahead and put a little arc here. Here's where our theta symbol is. Now be careful. Sometimes it feels like these triangles are flipped upside down. You'll notice the hypotenuse to this particular problem is actually the 40. See how it's directly opposite where the 90-degree angle is. So this is the hypotenuse. The adjacent leg to where that theta symbol is really the 32, and the 24 would be considered to be then the opposite. All right, so when we build these, sine is the so part of SOHCAHTOA, so that is opposite, that's the 24, over the hypotenuse, that's the 40, and then we should reduce that fraction, it would reduce to 3/5. When I build cosecant over here, I'm just going to take the reduced fraction 3/5 and put it over here and make it 5/3. Okay, for cosine, cosine is the ka part of SOHCAHTOA, so I'm going to be doing the adjacent leg over the hypotenuse. So that would be initially 32 over 40, which is going to reduce to the fraction 4/5. So when I come over here for secant, I'm just going to take 4/5, flip it, 5/4. Okay, and finally, tangent is the toa part that is opposite over adjacent. I'll be doing 24 over 32 as the initial fraction that I write down, and then when I reduce that, that reduces to 3/4. So for cotangent, I'll be writing down 4/3. Okay, there's going to be a few problems on your worksheet. They're going to ask you to find the exact values. When it says the exact values, that means you should not be recording any decimals. You should only be doing fractions or radicals if there were square roots in these problems. Okay, so only the fractions is what you should be reporting. You should really not be using your calculator unless you're using it to just merely reduce a fraction, but you're not pressing sine, cosine, tangent at all. Okay, so let's look at the next set of problems here. Again, they're saying to find the exact value, so I shouldn't be writing down any decimals at all, of the 5 remaining trig functions given for angle B in the triangle. Okay, so they give us one trig function to start out with. They give us sine. Okay, so I'm going to go ahead and fill that in. I know that sine is 5 over 8. Okay. Now, I guess if I know that, I could go ahead and fill in cosecant, because that's the reciprocal of sine. I could fill in 8/5. But at this point, that's probably all the farther that I can go, because I really need that third side of the triangle to help me out here. So I'm going to go ahead and write next to this fraction 5/8. Technically, they're telling me 2 sides of the triangle. I know that sine is the so part of SOHCAHTOA, so they're really telling me the opposite leg to angle B is 5, and that the the hypotenuse is 8. Okay. Now, I don't have to have a picture drawn for this. I know that something that's often done with right triangles is we are often working through what's called the Pythagorean theorem, which is where you take one leg squared plus the other leg squared, and that is always equal to your hypotenuse squared. Okay, you would have done something like that multiple times in geometry. So I need to find that other adjacent leg. Well, I know one leg is 5, that's the opposite leg. I'm missing the adjacent leg, so I'm just going to call that x, and that should be equal to the hypotenuse squared, which is the 8 squared. Okay, so I get this equation. I'm going to square off each of the numbers first, okay, and then I'll move the 25 over, That gives me x squared equals 39. 39 is not a perfect square, so I don't want to type in the square root of 39 on my calculator. I'm just going to leave it as the square root of 39. This right here is the adjacent leg. Okay, that's the adjacent leg. So now that I know the adjacent leg, I should be able to move down and answer what this fraction would be for cosine. Remember, cosine is the ka part of SOHCAHTOA, so it should be this adjacent leg, square root of 39, over the hypotenuse, which we said here, the hypotenuse is 8. Okay, when I do secant, I'm just doing the reciprocal of cosine. Okay, tangent, that is the TOA. So I'm doing opposite over adjacent. The opposite is 5, so that'll be my numerator. And the adjacent we said here was the square root of 39, so that'll be the denominator. And then, of course, cotangent is merely the reciprocal of that. Okay? All right, great. So let's go ahead and flip to the back here, where we're just going to spend a little bit of time here at looking at two special right triangles. These are really going to be important, especially as we move through to some of the later sections and we start looking at like the unit circle. Okay, so there are two special right triangles. One is called a 30, 60, 90 triangle. The other one is called a 45, 45, 90 triangle. Okay, obviously those numbers are telling you what the angles are. There are special ways that we refer to the sides of these triangles. Of course, the hypotenuse is the side opposite the 90-degree angle. But the side that's opposite the 30-degree angle is always called the short leg, and it will always be the shorter leg because it has a smaller angle opposite it. And so the side that's opposite the 60-degree angle, we call that the longer leg. Okay? But these sides have special relationships with each other. And really, the side that is the most important in a 30, 60, 90 triangle is the short leg. Okay? The short leg, if you were to take the short leg and multiply the short leg by 2, like just double the length of the short leg, that would represent the length of the hypotenuse. Again, this is something that you should have discussed in geometry. Okay, also, if you take the short leg and you multiply it by the square root of 3, that would give you the length of the long leg. So you can see how the short leg is really the most important leg in a 30, 60, 90 triangle, because once you know that, you could easily get the other two sides of your triangle. Okay, a 45, 45, 90 triangle, and we still have the hypotenuse opposite the 90-degree angle, but in a 45, 45, 90 triangle, this is actually an isosceles triangle, where the two legs, there's not a short leg, there's not a long leg. In fact, the two legs are actually the exact same length. And the key there is if you know the length of one of the legs, you multiply it by the square root of 2 to get the length of the hypotenuse. These formulas are something that you'll want to make sure that you commit to memory and you're comfortable with these relationships. So let's see if we can put them into practice with these three problems here below. Now, you'll notice what's challenging about these problems is I can't use the Pythagorean theorem to find the side that is labeled x because I don't know two sides of this right triangle. I only know one side. Okay, so they're giving us the hypotenuse is 8. They're asking us technically to find the long leg, but what you really need to do in a 30, 60, 90 triangle is you always need to find the short leg first. Okay, so the short leg is 30 degrees. If the hypotenuse is 8, now look up here, we said short leg times 2 is the hypotenuse, so that means if the hypotenuse is 8, this short leg would have to be 4. Okay, well now that we know the short leg is 4, it should be pretty easy to get the length of the long leg. Our formula says to take the short leg times the square root of 3, and you can just leave the square root of 3 symbol there. The long leg would be this 4 times the square root of 3. That would be the answer for x. Okay, let's look at the next one here. Here again, 30, 60, 90 triangle. Okay, now on this problem, they give us the hypotenuse, again, is 14, only this time look at where the x is. The x is the short leg. It's always opposite the 30-degree angle. Well, if the hypotenuse is 14, then the short leg should just be half that, so the short leg would then be 7. Okay, and then on this next one, this is a 45, 45, 90 triangle. You can see the information that they gave you on this problem is they want you to find the hypotenuse. They gave you the value of one leg. That's all you need. One leg times the square root of 2 will get you the hypotenuse in a 45, 45, 90 triangle. So that means the length of the hypotenuse is 10 times the square root of 2. Okay, that brings us to these last problems here, which is where we actually are now going to need to use our calculator. Now, it's going to be important anytime you are using those trig buttons, sine, cosine, or tangent. For right now, we need to make sure that our calculator is in the correct mode, and that mode needs to be degree mode. The default mode on your calculator is actually radians, so I'm going to walk you through how to make sure that your calculator is in degree mode before we move into these last few problems here. The mode button is to the right of the second key. If you could press that, you'll notice a couple rows down, you'll see where you have the option of either switching it into radians or into degrees. Make sure you bump over to degrees and press enter. Okay, that'll put your calculator into degree mode. Okay, now, what we're going to do in example 4 is they want us to use trig functions. Now, anytime we're doing this, we're going to revert to just our 3 basic trig functions, sine, cosine, or tangent. There are no secant, cosecant, or cotangent buttons on the calculator, so you're restricted to only being able to use sine, cosine, or tangent. We are exclusively trying to find the value of side x on these triangles. So here's what we want to do. We want to take the angle that we're given. I'm going to kind of emphasize that angle by putting a little arc there. I'm going to identify what the side is that I'm trying to find, that's the hypotenuse, and what the other side is that they gave me as it relates to the angle they also gave me. So this side that is 11, it looks like it is opposite the 24-degree angle. So it feels like I need to pick a trig function that's somehow going to incorporate the opposite leg with the hypotenuse. That feels like it might be sine. Okay, I want to use sine here. So I'm going to set up sine. Okay, after you put sine, this is where you put the angle. Sine of 24 degrees equals, then you put your fraction opposite, that's 11, over hypotenuse, that would be the x. Okay, this would be the equation that we would want to work with. Now, we're trying to solve this for x. So I'm going to make both sides of my equation look like a fraction, and I'm simply going to cross multiply. Okay, by cross multiplying, I can take an equation that had fractions in it, and I can make it so that we don't have fractions there, okay? So I'm going to cross multiply, and then to get the x by itself, I will need to divide both sides by sine of 24 degrees, and then this right here is what you would need to type into the calculator. So you're going to type 11 divided by, the sine button is right above the comma key, and then sine of 24, you're just simply going to round this to 2 places. Side x would be 27.04, and we'll label that units for the length of that side. Okay, let's try one more of these. We want to take the angle. I'm going to put a little arc here. Okay, 50 degrees, that's my angle here. Okay, side x looks like that's the adjacent leg, and side 12, well, that's the hypotenuse. Okay, so now I want to pick a trig function that's going to incorporate these 2 pieces together, adjacent and hypotenuse. Well, that feels like here I would want to use the trig function cosine. So I'm going to set up cosine of 50 degrees equals the fraction adjacent is the side that's x, hypotenuse is the side that is 12. Okay, again, I'm going to go ahead and cross multiply here. So I'm going to end up with x equals 12 times cosine of 50. That's what I'm going to type into the calculator. Okay, and when I type that in, I'm just going to put my answer right up here. 7.71 units would be the length of side x there. Okay, okay, last couple problems that we're going to look at is how to find a missing angle using the trig buttons on the calculator. Now, when you are finding missing angles, this is when you use what are called the inverse trig buttons on the calculator. If you look at your calculator, underneath the sine, cosine, and tangent buttons, it looks like it's sine -1, cosine -1, tangent -1. Some people mistaken those for thinking that this is cosecant, this is secant, and this is cotangent. That's not what those are. These are the buttons you use when you are trying to find missing angles in a triangle. So let me walk you through this here. This is asking us to find angle N. So I'm just going to kind of put a little arc here. This is the angle that we are trying to find, and they give you 2 sides. So I'm going to work with those 2 sides as they relate to angle N. 10. Looks like side 10 is the hypotenuse. Side 6 feels like it's the opposite leg. So I want to pick a trig function. Again, think back to so, ka, toa. The trig function that somehow is going to incorporate opposite and hypotenuse together. Certainly feels like that would be sine here. So I'm going to set up sine, but what you often put after sine is you put the angle. Okay, well, I don't know the angle, so I'm going to leave that as the variable n. That's what I'm going to solve for. I'm going to set that equal to the fraction opposite, that's 6, over the hypotenuse 10. Okay, now here's where these inverse trig functions come into play. This angle n is attached or glued to this trig function sine. And really, the only way for me to break apart the trig function from the angle is to perform the inverse trig function to that side of the equation. That mathematically is what breaks off the trig function from the angle, leaving just the n on the left side. Okay, of course we know that whatever we do to one side of the equation, we have to do the same thing to the other side of the equation. And you have to actually put this on the left side of your fraction here. You'll need to take the inverse sine of the fraction 6/10. So here's what you're going to do on the calculator. You're going to need to press that second button. Then you're going to press the sine key. That's really selecting inverse sine. And then you're taking the inverse sine in the parentheses there. You'll type in 6/10. Okay, usually we round the angles to the it says here the nearest tenth. That means 1 decimal place. So we're going to round that to 36.9 degrees. That's what angle n is. Okay, let's try one more of these here. Okay, here they're asking us to find angle B. So again, that's this angle down here. I'm going to make a little note. The 16 is the hypotenuse. Now the 8 is the adjacent. So I need to pick a trig function that somehow is going to incorporate adjacent with hypotenuse. That feels more like cosine. So I'm going to do cosine angle B equals adjacent 8 over hypotenuse 16. Okay, I want the B by itself, so to break that off, I'm going to do the inverse cosine. Need to kind of squeeze that in here to the left of my fraction here. This is what I'm going to type into the calculator to get angle B, inverse cosine, and then type the fraction 8/16 comes out to exactly 60 degrees for angle B. Okay, you can see I did this other one here for you just so you have another one to look at. But your homework assignment is for you to complete this worksheet 12.1.